So, we are often asked about the two ground pins that we have on our PicoConnect high bandwidth probes. Do we need to use both of these ground pins, or can we indeed use one, or are we okay to use little pigtail connections to the probe to make the ground? Well, whether you use two or one or pigtails does make a difference to the response that you get, and I'm going to share with you some of those differences, show you some of those differences, show you that they're quite small, but we need to be aware of them. So do excuse the jig that I'm using here. I take a piece of semi-rigid coaxial line or hand-formable coaxial line like this and file off some of the wall to expose the line inside to probing. Not a nice thing to do to a transmission line, you might think, but because it's very short, only a couple of millimeters or so, it actually has very little impact on the overall response of the line. My setup here, I'm using there's a PRBS generator down here. It's just giving me some wave shapes to share with you. And I suppose by using a PRBS generator we can indicate to you what data patterns might look like when they're probed in the various ways. So it's a PRBS generator. I'm sending the data pattern up through the line underneath the probe tip and directly to channel 1 on the 9400. This is one of the 4-channel 16 gigahertz models that I'm using here. This channel 1, the yellow trace, is going to show us the signal from the pattern generator, the signal passing under the probe, and we will be able to see the impact of us probing the line. We'll be able to see any differences that causes in the wave shape going forward to channel 1. Now we would expect that impact on the channel 1 signal to be very low. Why? Because the PicoConnect probes are low invasive probes. They're specifically designed to have as little impact as possible on the line that they're probing, and as I've said many times in the past, I believe, or we believe, that these are the least invasive probes available on the market, certainly at anything like the price level that we sell these at. When we say low invasive, what we're really talking about is the probe tip capacitance, the residual capacitance of the probe tip, and that's of the order of 250 femtofarads typically for these probes. Even with the very low tip capacitance, we do have to think about these ground connections and in particular their inductance. I would argue that all probes should be designed in this way, with 2 ground tips either side of the main probing tip. The reason for that is that ideally we want to contact our line with another transmission line, a perfectly formed transmission line. Certainly it needs to be of higher impedance than the line we are probing, so if we're probing a 50 ohm line, we'd want to contact with a much higher impedance. I suppose ideally we would like this ground to be a circular ground surrounding the probe tip, such that it makes a coaxial transmission line that we can touch on the other on the line under test, but it's not very practical to do that. So a next best option is that if we put 2 grounds either side like that, we can make a coplanar transmission line with the 2 grounds either side of the tip. The impedance of the line is created by, 1, the diameter of the probes probe tips here, and also their spacing, and that's why the spacing is relatively wide. We want to try and make a transmission line of a relatively high impedance, and with this spacing of these tips we're achieving something like 200 to 250 ohms as a transmission line into the probe. Now when we use the probe, the use of either one or two ground pins does make a difference to the response. And as I say, we're going to share that with you, as you will see. We'll also look at the response when we replace both pins with pigtails. So first waveform, let's just remove, I'm going to remove that from the pin, from the pigtails. I'm going to fit the two ground pins that we provide with the probe, move the pigtails just aside, and let's see if we can make contact and capture ourselves a trace. Okay, so as you can see, I recorded the through line trace, the yellow trace. I recorded that beforehand, and you can now see that I've loaded the line slightly with my low impedance probe, but only slightly, and most importantly I've only changed the amplitude. The shape of the waveform has been very little affected. In fact, you can just see a little bit of loss of overshoot on the waveform there. Let me save the probe trace there, and then take out one of the ground pins and reprobe the line. Save that one. Remove the other ground pin. Fit the probe to both pigtails. And then finally move one pigtail aside and just use one of the pigtails. And this time I shall have to steal back the memory trace, memory 1. There we go. And now we can turn off channel 3. We can see, can't we, that the blue trace taken with the two ground pins, that's definitely going to be the fastest and probably the most representative of the true wave shape. We can see that when we used two pigtails, that's the red trace, that again was pretty representative, but we certainly lost some overshoot, probably some edge speed. This is due to the increased inductance of the pigtails. The next most inductive was the use of single pin, the green trace. Finally, the single pigtail was ever so slightly more inductive still. Let's get some measurements on each of those waveforms. And there we go. So I can let you run through those yourselves, but we've got amplitude and rise time in each case there. You should see that the amplitudes are about 859 millivolts is on the through line at the moment. And what have we got? 851, 851, 800, all well within specification there via the probe. And the probe, of course, is compensated for its divide by 5 ratio. The rise times there, what have we got? 41 picoseconds on the through line at the moment. Memory 1 is the measurement taken from the single pigtail. So the most representative again was definitely the first probed measurement, the blue trace, where we used 2 ground pins. So what does this all mean? Do we have to use 2 ground pins, or can we use just 1? Can we use pigtails? Well, the answer is it's a bit similar to the case of the ordinary and very common scope probe. Can we use the crocodile clip and this long inductive lead, or should we wrap a bit of wire around that ground ring there and make a little pin, ground pin, or maybe 2? Or should we use an interface like this and plug ourselves directly into a coaxial point? Well, you can't always use that, of course, so we'll put that to one side. I think most of us know that the piece of wire wrapped around the ground here and maybe soldered to the board for high frequency work, that's probably the best. And the crocodile clip really isn't that great, certainly not at higher frequencies. But of course this is convenient, and so very often we do use the crocodile clip. Well, and we take the compromise. We take the waveform or the bandwidth compromise, and it's a bit similar with these probes, but at much higher frequency. Really, we should use both grounds. That's ideally. But if we don't, then the response differences that we see here, the overshoot, perhaps a dB and a bit above the flat line. The undershoot here, the worst case, perhaps a dB below, dB or so below. You make a small response compromise if you don't use the 2 ground pins. But for many measurements that you make, you will be able to accept the compromise in response of just using 1 or of just using a pigtail. So really, it's all down to the application. Do I need the very best response? Am I trying to characterize an eye, for instance? Probe the eye, but use 2 grounds. If I'm just trying to look-see, maybe use just 1. Okay, thank you very much.